Hi, everybody. I was really looking forward to doing this one. This is BB.7, which is solve a quadratic equation using the zero product property. So anything, when we know that we're multiplying two things together and we get zero, we know that one of the factors has to be zero. And we're going to use that and factoring to solve these. Well, in this particular case, we didn't even have to factor it. They told us that C times C plus 5 was equal to 0. So what we know, because of the zero multiplication property, is that either C is equal to 0 or the C plus 5 is equal to 0. And if this is 0, C is -5, isn't it? So either one will make it true. If C is 0, then 0 times 5 is 0. And if C is -5, -5 times 0 is 0. So it works either way. So we have 0 and we have -5. We're just looking to make zeros out of our factors. We call those factors. Now this time we want this part to be 0. And if u is -2, then this piece will be 0. This piece will be 6, but realize 0 times 6 is 0, isn't it? And if u is -8, then we end up with -6 times 0, which is also 0. So either way, as long as one of them is 0, it's okay. So u could be -2 or -8. And that's it. We're just looking for the zeros. We call these things zeros or roots. In this case, it could be 0 for the first one or 6 for the second one. Again, those are zeros or roots. Q could be -8 or 0. Now, formally, if I were to write this formally, we would say that because this times this, A times B is 0, one of them has to be 0. So a good idea is you could write either 2u plus 1 equals 0 or 8u minus 1 is equal to 0. And you would solve these as two separate equations. Hopefully you can solve them in your head, but if not, you subtract 1 from both sides. So I had to lose a little bit there. That gives me 2u equals -1, and then we divide by 2, and we get u equals -1/2. And because we do the same thing every time, we're going to add 1 and divide by 8. We get 1/8. But I'm going to go ahead and write it. Plus 1, plus 1. That's 0. That gives me 8u equals 1. And then we divide by 8. And what you'll find is that it's the same process over and over again. And you'll be able to recognize it and do it in your head most of the time if you practice a little bit. So 1/8 will make this 0, won't it? And -1/2 will make this part 0. So that's what we're looking at. So this one is going to be -6 will give us a 0 in the first factor. And the second factor, we need a 7. That's it. And the first factor, we need 0 or -3. This one, can you solve this one in your head? You only really need to solve that one. That one's going to be 3, isn't it? And this one is going to be 4 over 3. You just add 4, divide by 3. I'll write it out one last time. 3q minus 4 equals 0. I'm adding 4 to both sides. I get 3q by itself is equal to 4, and then I'm dividing by 3. And of course, I get 4 over 3 for q. And 3 for the other one. So this one is going to be 5 for the first one. That's my first term. That's going to give me my 0. And in my second one, I'm going to have -5 over 2. I subtract 5 on both sides and then divide by 2 on both sides. You can do it in your head. I know you can. This one is going to be 0, or subtract 7 and divide by 4. This one is going to be -8 or -4. We call these zeros because, by the way, the whole point to this is that we're going to be able to solve equations like these. Notice that this is the same thing that you see written there. You see this equation, this quadratic equation, has been factored in this term, in this particular instance. And the whole idea is that we will be able to solve equations like this through factoring and then using that zero multiplication. So what I did is I set each of these factors equal to 0 and found the zeros of this function. Couple of things that this allows us to do is to graph things like this. You see, I know that this thing has zeros at -4 and -8. And of course, the y-intercept is at 32, which is up off the deal here. But this vertex is right in between those two values, which is going to be -6. It's going to be -6 something. And we can find it. We use -b/2a, and we substitute it in, and so on. But the whole point to the exercise is that these zeros are called roots or zeros. They will make this particular function 0. And of course, they solve this one. So that's the reason that we're doing this, is to practice. All right, we have -9/2. I subtracted 9 on both sides and then divided by 2. And then for this one, I added 1 and divided by 6. And there you go. In this one, we have 9r equals 0, but notice that 9r equal to 0, still just 0. Dividing by 9 is okay. Just remember, if 9r equals 0 and we divide by 9, you are allowed to do this. It's what you can't do is you can't divide by 0. You can divide into 0, because we're just asking how many 9s fit into 0, and there are 0 of them. And another way to think of it is that 0 times 9 is still 0. The other one, of course, is 3, and there are my zeros. Roots, they're sometimes called solutions. This is a solution to this equation. By the way, this one was 49j squared minus 9 equal to 0. And in one of our last sections, we would add 9 and divide by 49, and we would get -3/7 or +3/7. But of course, if we solved these, we would also get 3/7, -3/7, or just 3/7. This was the binomial that goes with this a minus b, a plus b. Okay, looks like we have a 2/9. I added 2 and divided by 9. And -6. Those are my zeros. We'll call them roots this time. I divide by -3 and get 0, or -7/8. Those are my two roots, or my two solutions, or my two zeros. This is going to be 0 or -6. This is going to be, you're going to subtract 9 and divide by 5. And subtract 4, which is just -4. Those are my two zeros. This one is going to be 0 or 9. Okay, this one's a little different. We have a negative on our variable. It doesn't matter. It just means that it's going to be 2 instead of negative 2, isn't it? So that's going to be 2. A positive 2 will make this 0. Putting in a negative in front of that 2 will give me 0 there. And for this one, I just solve it. I subtract 4 and divide by 3. Gives me negative 4/3. And we're done. One way to think of this is you subtract the 2 and then divide by the negative 1. But it's easier to just see that the 2 for the p will give me a negative 2. So I really should put the parentheses around that. There we go. Hopefully that was clear. This one is going to be 2 over 5. I added 2 divided by 5 for the first part. And then we subtracted 3 and divided by 2. And got negative 3 over 2 for the second part. For the second factor, I should say. For this one, we're going to subtract the 1, but then we divide by negative 3, which means we have a positive 1/3. I'm going to go ahead and write this one because I know it's a little different than the others. Negative 3h plus 1 equals 0. We're subtracting 1. Sorry, I'm kind of losing it there. I'm subtracting 1 from both sides, and I get negative 3h equals negative 1. And then when I divide by the negative 3, that does give me a positive 1/3. So this one is 1 over 3. And this one, of course, is negative 5 over 6. And we're done. In this one, we have a negative 9 over negative 2, which ends up being positive 9 over 2. And in this one, we have a negative 8 over 9. Hopefully that's clear. You guys could go ahead and write them out if you wanted to. This one is going to be negative 1 over negative 6, which is positive 1 over 6. And this one is going to be 1 over 9. I think I'm going to go ahead and write this one right there. I have a negative 6m plus 1 equals 0. I subtract 1. I get negative 6m equals negative 1. Dividing by negative 6 does give me positive 1/6, doesn't it? See that? And we end up with negative 1/4 this time. See, that's going to be plus 1 on both sides and then divide by a negative 4. So I'm going to end up with a negative 1 over 4. And in the second one, we add the 5 and divide by 7. And we're done. In this one, we're going to subtract 5 over 8, negative 5, and divide by 8 on both sides. And then we're going to subtract 7, but we're going to divide by negative 8. So we have a negative over a negative, which is 7 over 8. And that's it. For this one, I'll go ahead and show it to you. Negative 8u plus 7 equals 0. We subtract the 7. And we get negative 8u on this side is equal to negative 7. We divide by the negative 8. And that gives us a positive u equals positive 7 over 8. That's why we get the positive. And in this one, we have an 8 over negative 9. But 8 over negative 9 is the same as negative 8 over 9. Either one would be correct, but I like this one better. This one gave me the positive 8 over negative 9, which is the same thing if they put the numerator as negative. I like that one better. And then in the second one, we have 3 over 8. That's it. Looks like we have one last one. We have a 3 over 5 and a positive 5 over negative 4, which is the same thing as negative 5 over 4. And that is my y value. I just added 5 and divided by negative 4, and then I've changed it to the numerator. Negative 5 over 4. And we are done. I hope you guys will do yours as well. Hopefully it wasn't too painful. I'll see you back again. I'm looking forward to doing the factoring. I love the factoring ones. Bye, guys.